Far beneath the calm Pacific waves, the axial seamount has begun to stir, shaking with thousands of tremors a day, each one a warning from the planet's hidden engine. Scientists say this submarine volcano, just 300 miles off Oregon's coast, could trigger a chain reaction strong enough to reshape the ocean floor and ripple toward the continent. Pressure is rising, magma is moving, and the signals point to an eruption window that may already be opening. Could this be the moment when the West Coast's greatest hidden threat finally breaks into the open?
Far from the orderly crosswalks and sunlit neighborhoods of Oregon, where wind leans through spruce and morning fog drifts between towns, another world pulses below, a world of darkness, heat, and titanic movement, 300 miles off the familiar coastline, beyond the last reach of fishing boats and the curiosity of recreational sailors. A domain both ancient and restless thrums beneath 1,000 fathoms of water. Here, in the cold Pacific depths, the Axial Seamount, a name barely whispered outside science circles, is awakening. Unlike the celebrated peaks of Rainier or St. Helens, the Axial Seamount receives no tourists and draws no postcards. Its presence is rarely acknowledged on land, yet those who watch it know. This volcano is not only one of the Pacific Northwest's most active, it is also one of its most enigmatic. Recently, its core has been shaking with thousands of tremors, each one a coded message from the planet's buried heart. Each one raising the tension within a vast invisible chain that links everything from mud on distant beaches to the grind of continental plates. Scientists, operating from research vessels and land-based observation posts, monitor the signals with a kind of reverent urgency. They are familiar with axial cycles, with its ominous silences, and with the restless anticipation that surrounds this leviathan when it stirs. These days, their eyes rarely shift from their screens. They know well, an eruption, unseen by any living soul, may soon shape events along the underwater landscape and potentially influence broader geological dynamics. The origins of this story lie far beneath the ocean's reflective skin. But what are these tremors truly warning of? And how might the awakening of a single volcano ripple through the natural systems connected to the West Coast? The watchers below the waves. Beneath every calm surface rests a stage for unseen drama, nowhere more so than in the Pacific Northwest, where the deep ocean obscures forces vast enough to rework coastlines and reorder the future. The Axial Seamount, rising from the ocean floor like an immense, inverted mountain, forms a living reminder of how much we overlook. Hidden by 1,000 meters of water, it is both shielded and sealed, its eruptions offering no smoke columns or raining ash, only subtle changes, measured by the patient instruments of science. It is here, in a zone marked by neither buoy nor beacon, that researchers have devoted themselves to the art of listening. The process is both methodical and fraught. Arrays of seismometers dot the seafloor, their sensitive ears vigilantly pressed to stone. Fiber optic links thread their way to distant research centers, carrying the soft, insistent beat of tectonic unrest. What separates Axial from so many other volcanoes is not simply its isolation, nor its concealed magnitude, but the persistent and relentless tempo of its activity. Over recent weeks and months, the ground beneath has been humming, struck by upwards of 1,000 measurable tremors each day. Each quake, no more than a whisper on shore, is noted and cataloged. Patterns are sought. Anomalies become the focus of sleepless debate. In crowded control rooms and shipboard galleys, conversations drift toward the inevitable question: is this the beginning, or merely the latest cautionary tale from a place that never truly rests? Axial last erupted in 2015, erupting in silence so profound as to be missed by all but the most attentive watchers. Now, the signs are louder, the chain of forces more distinct. The sum of these tremors, their frequency and shape, point to new magma rising, a pressure bottling up, seeking escape, threatening to redraw the ocean floor and create changes in the undersea landscape. Yet, amid all the data, a stubborn uncertainty persists. Each graph and waveform hints at escalation. But how to know if the chain will break suddenly or hold, coiled and locked, beneath the unsuspecting calm? The unfolding chain. To follow the growth of pressure beneath the axial seamount is to follow a growing chain of cause and effect, one whose first links are hammered thousands of feet below, but whose echo stretches toward the distant land. Each tremor, insignificant alone, becomes part of a narrative as old as the planet itself. Imagine, beneath the Pacific, two tectonic plates move with irresistible might. At their margins, fractures widen and magma wells up to fill voids. The seafloor, stitched together by a web of faults, heaves and sags, each movement sending a shudder through the Earth's structure. Above, the water churns, aware only in the smallest way, yet sensitive enough to transmit disturbances at astonishing speed. It is this web of pressures and releases, this orchestrated chain, that captures the focus of scientists. They pore over seismic scans, searching for clusters, zones where the tremor count surges into the thousands, their energy stacking, amplifying, threatening a collective lurch. Occasionally, equipment records a microquake, so precise in timing and locale that it appears programmed, each representing another block, shifting in a wall under siege. The historical record gives little comfort. In 2015, when Axial last broke open, the world above noticed little. Yet the event produced new lava flows, expanded hydrothermal vents, and slight shifts in ocean chemistry that were detected by scientific surveys. What might a larger eruption unleash? What parts of this chain, far from being closed, might now be charged for a sequence of events noticed by instruments, and perhaps, eventually, by observers above? As scientists consider these possibilities, they understand the chain is not a straight line. Each link joins another in unexpected ways. The energy of one quake may be spent harmlessly into the deep, or it may tip another fault, provoke a slide, or send a pressure wave traveling for miles beneath the continental margin. Even now, as graphs scroll with each passing hour, the question sharpens: how many links must fail before the system changes irreversibly? Signal through darkness. Yet the chain of forces running from axial seamount is not only a matter of physical stress and fracture, it is also a puzzle of signals, whispers in the dark, patterns so subtle they almost escape detection. Each day, teams comb through the records, visualizations of hundreds, then thousands of quakes, etched as spikes and valleys. In labs and onboard research ships, the tension rises with every unexplained burst of activity. Sometimes, an alarm sounds. A sudden concentrated swarm signals magma movement, or pressure readings hint at ground uplift. In these moments, a stillness claims the observers, as if the deep were leaning forward to speak. But these signs are embedded in noise. The ocean is a stage of constant motion: gales, tides, migratory whales, the work of underwater landslides and distant storms. Scientists, engineers, geophysicists have grown wary of false alarms. Yet Axial's pattern is unmistakable when one knows what to look for. A rhythmic accumulation, a drumbeat of unrest, a slow, steady charge. Specialized hydrophones, pressing their artificial ears to the abyss, sometimes pick up more than tremors. Odd vibrations, persistent hums, and the unmistakable signature of rocks cracking under strain. At times, the data spikes, bursts of energy so sudden that equipment, momentarily overwhelmed, falls silent, then resumes recording. What does it mean when the familiar pattern of unrest bends into unfamiliar territory? In staff meetings, doubt and excitement often mix. A false positive might lead to unnecessary concern, but a missed warning could mean a lost chance to observe one of the great cycles of planetary renewal. And what of the surface? For now, beaches and cities remain unconcerned, but what chain of events could start down below and eventually affect the ocean's natural balance, ecosystems, or even, in rare cases, make itself known at the shoreline? Forecasting the unthinkable. To the public, the notion of forecasting an underwater volcanic eruption may seem impossible, yet at Axial Seamount, the science has grown sharper, the methods more exact. Pressure sensors, some anchored for years in the darkness, capture every subtle swelling of the volcano's flanks. When magma pushes upward, the ground lifts by centimeters, fractions of an inch, yet enough to send instruments blinking into alert. Over years, scientists have built a signature for Axial's preparations. Discrete stages unfold, initial tremor swarms, intensifying seismicity, then a narrowing of quake depth, ascending nearer the surface, like footsteps approaching. Uplift accelerates. Chemical measurements from hydrothermal vents turn erratic, sometimes clouding the water with minerals as pressure escapes through unseen cracks. Each set of observations is logged, compared with historical episodes, teased for commonalities. The 2015 eruption, their best case study, refined what was assumed about underwater prediction. The lessons: pay attention to frequency, to ground deformation, to outliers. The waiting game is not passive. It's an exercise in attention, in pattern recognition, where the cost of distraction is high. Even so, this chain of evidence brings its own burden. Scientists know that their alerts carry weight, that a missed signal means not only scientific failure, but the potential for an undetected natural event beneath the waves. While the volcano's readiness to erupt may not be in doubt, the timing and exact consequences are subject to uncertainty. Magma pressures rise, tremors escalate, equipment, approaching its technical limits, churns out warnings that become less hypothetical by the hour. How should communities, most of whom have never heard of Axial, respond to the findings of scientists? And how robust is this chain of surveillance, dependent on sensors, research ships, and continued funding, in providing not just data, but clarity? The surface connection. Above the churning deep and restless volcano, the west coast carries on, its own chain of human activity, largely unaware of the drama beneath. The nearest landfall, hundreds of miles away, hosts fishing towns, cities, ports, and refineries, all bound together by busy highways and tangled histories. Yet beneath the waves, every tremor at Axial Seamount might begin a ripple that over time could influence ocean currents, ecosystems, and the shape of the seafloor. Previous eruptions at Axial have left marks invisible to casual observers. New mounds of pillow lava, shifts in undersea vent systems, and plumes of mineral-laden water rising through the darkness. These events have, so far, spared the surface any immediate shock, but they are not without consequence. Each disruption alters currents, changes chemical gradients, and sets into motion a cascade of ecological adaptation among undersea communities. Still, scientists are mindful of more dramatic but less likely scenarios. A sufficiently massive eruption or a series of connected events could in theory send strong seismic waves toward the continental shelf. Under certain conditions, such unrest could provoke localized landslides on the seafloor, their momentum carrying sediment into deeper waters. In unusual cases, undersea landslides can generate tsunamis, although this outcome is considered rare and would require many factors to align. Modeling suggests most eruptions will remain contained, their violence muffled under tons of water. Yet the chain is not infallible. It takes only one link, one abnormal sequence, one break in the underwater mountains to send shocks traveling far from the source. Emergency planners, briefed by scientists, draw up response strategies, and communicate findings to local authorities. Drills remain largely theoretical while the threat is remote. But the new tempo at Axial has cast a cautious shadow across planning tables. So, when does the chain of deep-sea events become a chain of consequences at the surface? And how many warning signs will be needed before the coast and the continent takes notice? Standing guard at the edge. Each day, research vessels circle the coordinates above Axial Seamount, their work both monotonous and significant. Oceanography teams, armed with remotely operated vehicles and pressure loggers, lower instruments down into the darkness, mapping the seabed, recording its temperature, chemistry, and the tiniest mechanical shifts. Their operations reveal much. Fields of newly cooled lava, plumes of hydrothermal fluids rising amid silence, and, most recently, the increase of earthquake swarms in specific zones. The equipment, calibrated to detect fractions of movement, records the seafloor's slow rise and fall, as if the Earth were drawing a deliberate, unstoppable breath. On board, the language is precise but hushed. Magma intrusion, ground deformation, seismic swarms, terms that mark a transition from routine monitoring to focused observation. The vessel's comms remain busy, relaying updates to shore. Uncertainty is their companion, and the sense that something significant is unfolding just beneath the ocean's calm surface never quite leaves. In recent days, the daily tremor count has not plateaued, but sometimes increased, shifting in both pattern and location, perhaps signifying dynamic processes deep within the volcano. Computer models move through various scenarios: minor venting, larger eruptions, and changes in the geometry of the volcano itself. Scientists compare these signals to those recorded before the 2015 eruption and see important differences. Greater seismic energy, more abrupt clustering, and variable ground deformation. What these changes portend is not entirely certain. Are they indicating an eruption larger than previously witnessed, or do they represent the volcano's natural variability? Far away, along the Oregon coast and beyond, life continues, trusting the calm sea. But those on watch at the ocean's edge recognize that the fate of the surface and the depths are, in complex ways, always connected. Chains unseen beyond the volcano. As researchers track Axial's rumblings, their attention inevitably expands outward to the distributed system of undersea ridges and transform faults that form the Pacific Northwest's tectonic landscape. The volcano, while singular in name, is one node among many in a global web of submarine volcanism and plate motion. Each movement at Axial can disturb its neighbors, a distributed chain of unrest felt along the boundaries west of the United States. Every surge of molten rock, every microquake, may subtly change stress levels along underwater faults, sometimes influencing nearby geological structures. History shows that undersea volcanic activity is often part of broader tectonic cycles. The evidence is complex. Stress must redistribute itself somewhere. Sometimes it is spent deep at sea, opening new vents in remote places. At other times, tectonic energy finds weakest points elsewhere, sometimes near the shore. The possibility that Axial's ongoing sequence could influence other geological features serves as a reminder that no volcano acts alone. Each shift, each release of pressure, holds the potential to set off new patterns of unrest. But direct, immediate links to mainland earthquakes are not established and remain an area of research. Testing the limits. In laboratories along the coast, Every day brings another stack of data. Algorithms sift through the catalog tremors, searching for statistical clues. Teams debate over the likelihood of various outcomes, over significance, over the duty of those who interpret the signs. One thing stands out: forecasting at a site so remote, so shielded by depth, will always be constrained by both technology and the inherent unpredictability of nature. There are mechanical failures, lost data, and the ever-present risk that a critical signal could be missed. And there is a human side, interpreting ambiguous signs, weighing the risk of action against the risk of silence. 1,000 tremors a day, a number almost unimaginable if felt on land, arrive instead as numbers, as digital graphs, as temporary spikes in data streams. Yet each one is real, a mark of subsurface strain and change. Some scientists, wary from earlier cycles of warning, prefer caution. Others, alert to the current escalation, emphasize outreach and readiness. At briefings, the debate returns. Is this the moment? Will the chain hold? Or are we witnessing a new chapter in oceanic volcanism? The Unraveling Hour time, for those monitoring Axial, is both friend and adversary. The continuous chain of signs, building steadily, brings the prospect of another eruption closer. Onboard ships and inside labs, anticipation grows. Each data point another line preparing to be written in the history of the Pacific. Onshore, news of increased seismic activity offshore occasionally appears, and emergency managers routinely review relevant plans. For many residents, such information is a distant concern, but for those familiar with the ocean's potential for swift change, it maintains a steady note of vigilance. Still, it is not easy to translate scientific caution into public urgency. The ocean, vast and seemingly unmoved, hides its ferment underneath blue tranquility. As scientists predict that Axial may erupt again soon, possibly as soon as 2025, meetings grow more frequent. Equipment is checked and rechecked, and monitoring intensifies. Teams rotate to avoid fatigue, tracking ground deformation and seismicity in real time. Then, perhaps in the space of a few moments, an alert signals a burst of seismicity, activity that could indicate the final buildup has arrived, or that may yet subside and become another footnote in the volcano's long cycle. Ships wait, instruments record, and onshore, scientists prepare to analyze in detail whatever follows. What, they ask themselves, will the evidence show the day after Axial's chain of events unfolds? Returning to the surface, as the expected eruption window approaches, the reality behind Axial Seamount's 1,000 daily tremors comes into focus. From silent depths to scientific headlines, what was once mere data has become the basis for new understanding. A chain connecting the deep time and space of the ocean floor to the restless pulse of science. For those who study Axial, the answers are never final. Each prediction brings new questions, each dataset a fresh challenge. For now, the world above knows only that there are powerful forces playing out beneath the surface, forces that, while rarely felt directly, maintain a steady presence at the edges of possibility. As ships return to port and labs find a rare moment's calm, the lesson endures. The coast, with its rivers and mountains, is shaped not only by what can be seen, but by what moves, unseen, beneath the waves. And so, the chain holds another day, or perhaps tightens one step further towards something new. If this story of unseen forces shaping our world left you as awed and maybe as unsettled as it did us, be sure to share your thoughts below. What do you think lies beneath the surface? waiting for its moment. Don't forget to subscribe for more explorations of the unknown. And until next time, remember, what we stand on is only the beginning.